All right, welcome. Today we're going to crack open one of the most powerful toolkits any C++ developer has at their disposal, the Standard Template Library, or as you'll hear it called, the STL. We're going to see how this thing can save you a ton of time, help you squash bugs, and make your code way, way more efficient.
So let me ask you this. Have you ever found yourself coding up yet another linked list? Or maybe a dynamic array for the 100th time? You know that feeling, right? It's just so repetitive, it eats up your time, and honestly, it's super easy to introduce a sneaky bug. But what if there was a better way?
Well, there is, and it's called the STL. Just think of it like a massive library of pre-built, super optimized components that are ready to handle all that heavy lifting for you. It really is the ultimate programmer's toolkit, and it's all designed to make your code more robust, more efficient, and frankly, just a lot easier to write. So let's really lean into this toolkit idea. The STL isn't just some random collection of code, you know? It's a fundamental core part of modern C++ that gives you all the building blocks you need to create some seriously complex and efficient software. So why should you be reaching for this toolkit? Well, first up, reusability. I mean, why reinvent the wheel when you can use components that have been written, tested, and perfected by countless experts? Second, efficiency. The stuff in the STL is incredibly fast. These data structures and algorithms are highly optimized. And finally, you've got flexibility. Because of C++ templates, these tools don't care what you throw at them. Integers, strings, your own custom objects, anything you can dream up. It'll work. All right, let's pop the lid on this toolkit and see what's actually inside. What are these main components that make the STL so incredibly powerful? Turns out, the power of the STL really boils down to 4 fundamental components that all work together beautifully. If you can get a handle on these 4 pillars, you've basically unlocked everything this amazing library has to offer. Okay, so first, we've got containers. These are like the storage boxes where you keep all your data. Next, you have algorithms. Think of these as the power tools, like your drills and saws, that do things like sort and search through that data. Then you have iterators, which act like your hands, letting you move through the containers and grab the data you need. And finally, you have functors, which are kind of like custom attachments for your power tools. Now, all 4 are super important, but today we're going to zero in on containers because they are the foundation you'll be building on most of the time. So for this explainer, we're really going to focus on the component you'll use day in and day out, the containers. These are the actual data structures themselves. And let me tell you, choosing the right one for the job is one of the most important decisions you'll make when you're coding. Okay, so the first and probably most common type of container is the one that holds your data in a linear sequence. Just imagine a line of people waiting for a bus. The order you put them in is the order they stand. These are the real workhorses for most of your ordered collections. And right here, this is where you see the crucial trade-offs. A vector, it's basically a dynamic array. It's super, super fast to access any element if you know its index, but it's really slow if you need to stick something in the middle or delete from the middle. Now, a list, that's a doubly linked list, is pretty much the opposite. It's amazing for insertions and deletions anywhere in the collection, but trying to jump to a specific element, that's going to be slow. And then you have DQ, or a double-ended queue, which is a cool hybrid that's fast at adding or removing things from both the front and the back. But hey, what if you don't really care about the sequence? What if you just need to find things fast? Well, that's where associative containers really shine. They store data in a sorted structure, usually something like a balanced binary tree. This means searching is incredibly efficient. We're talking O of log n complexity, which means as the collection doubles in size, it only takes one extra step to find what you're looking for. It scales beautifully. The 2 main players in this category are set and map, and the distinction is actually really simple. You use a set when you just need a sorted collection of unique things, like say a list of unique usernames. And you use a map when you need to connect a unique key to a value, like mapping that username to a specific user ID. Simple as that. But what if log n still isn't fast enough for you? For the absolute maximum pedal-to-the-metal lookup speed, we turn to unordered associative containers. Instead of using a sorted tree, these use a hash table. And this technique gives you almost instantaneous access, and it doesn't matter how big the collection gets. The result is an average lookup time of O of 1, or constant time. What that means is, on average, it takes the exact same amount of time to find an item in a collection of 1,000,000 elements as it does in a collection of just 10. It is, for all practical purposes, lightning fast. And finally, we've got container adapters.
Now, these aren't really new containers. They're more like wrappers that sit on top of other containers to give you a simpler, more specific way of working with them. So a stack gives you last in, first out behavior, just like a stack of plates. And a queue gives you first in, first out behavior, just like a checkout line at the grocery store.
Okay, so we've seen all the cool tools in the box. Now for the most important part of all. How in the world do you know which one to pick for the specific problem you're trying to solve?
Well, let's make it easy. Here is your practical cheat sheet. If you need a simple, flexible list, just start with vector. Honestly, it's the default choice for a reason. If you need to look up values by a key as fast as humanly possible, unordered map is your best friend. Want to keep a sorted collection of unique items? Set is perfect for that. Need a simple lineup, first in, first out. Use queue. And if your main job is constantly adding and removing things from the middle of a big collection, list was designed for that exact task. So after seeing all these pieces, let's just take a step back and really appreciate why the STL is so incredibly important for modern C++ development. It gives us a shared, standard toolkit that every single C++ programmer knows and can rely on. And that saves an unbelievable amount of time and effort. It also gives us a common language, right? When one developer talks about a vector, another one knows exactly what they mean. And at the end of the day, using the STL just leads to code that is faster, safer, and way more maintainable. And that really is the core idea here. The STL isn't just another library. It is the solid foundation that high-performance, robust applications are built on. It empowers you to focus on your app's logic, not on reinventing the low-level details of a data structure. So, the toolkit is officially in your hands now. You've seen the containers, you understand the trade-offs, and you know how to choose the right tool for the job. The only question left is, what amazing things are you going to build with it? Thanks for tuning in to this explainer.